Hello everyone. Today we are going to learn parallel processing. This is one of the most famous topic. It is always very important for the exam point of view also. So we need to explore this topic in very detail. Before starting with the parallel processing, first of all we need to understand what is parallelism. Parallelism is a topic which is taken from the study of management. There we learn that parallelism is the mechanism of executing more than one activity simultaneously. When we talk about the project management, then we learn parallelism. There we learn the ability to execute more than one tasks, more than one activities simultaneously. Now a question turns up that why should we execute more than one activity simultaneously? The answer is that we would like to complete the project before the estimated time. If you want to achieve efficiency, if you want to get the project completed before the time, if you want to get the uh, efficiency of the project management, then we adopt the path of parallelism. The same concept is taken in the computer science in designing the computer microprocessor. The whole computer architecture are based on parallel processing nowadays. So what happens here? We learn that the microprocessor is designed to execute one instruction simultaneously. First of all, we learned micro instruction. What is micro instruction? When we execute our program, our instructions are broken into small instructions which a microprocessor executes. And one instruction is executed at a time. This is the usual nature of microprocessor. So if we have 1 million instructions and suppose a fraction of second is taken to execute one instruction at a time, what is the total processing time? The time taken by the microprocessor to execute one micro instruction multiplied by the total instructions available. Now here we apply the parallelism. Nowadays, most of the microprocessors are based on parallel processing concept. What happens? More than one instructions are sent to microprocessor for the execution. Now, how does it goes? First of all, we need to understand the common. It is a recap. We have already learned that all the instructions are available in the main memory, means RAM, and when it passes through microprocessor, this is microprocessor. This is microprocessor. In microprocessor, the instructions goes to registers. Main memory unit means registers. The memory unit is nothing but an organized collection of registers. We have learned registers in very detail in separate 2 lectures. Now, from the memory unit, the required instruction goes to control unit, and the control unit controls everything and moves to ALU for the execution. After execution, backs to control unit and backs to main memory. The main memory is an organized collection of registers. What registers are available? We have learned about accumulator. We have learned about instruction register, program counter, memory address register, memory buffer register. Now, accumulator stores the result of the processing, means the ALU processes the instruction and returns the result, that result is stored in accumulator. What is the role of instruction register? Instruction register stores the actual instruction, that instruction which is being executed right now. And what is program counter? Program counter keeps the address of the next instruction to be processed. Now, how the thing goes? One instruction is fetched by memory address register and memory buffer register. goes to program counter, and from the program counter it moves to instruction register. And sitting in the instruction register, it means that instruction is getting processed. When the instruction is getting processed, after completing the process, it returns the result, and that result is stored in the accumulator. Next, what happens? The program counter holds the address of the next instruction to be processed. Address of the next instruction, not the instruction itself. Once the processing is done inside the microprocessor, program counter gets activated and it moves to the main memory to fetch another instruction that has to be processed. The another instruction is getting fetched to be processed. During that period, ALU is sitting idle. ALU is doing nothing. This is the wastage of time. So what if the instruction is getting processed? It would be better that during that period itself, the program counter should move towards the RAM to get to fetch that next instruction to be processed. It would have saved the processing time. So parallelism is a concept that we can apply at various levels of the processing. If we are applying we are changing bit in the technology of this processing. When an instruction is getting processed, during that time only, if program counter moves to the main memory to fetch the next instruction to be processed, it is also a kind of parallelism. So parallelism can be applied by various ways. First of all, we need to understand how can we make it possible to process more than one instruction simultaneously. There are various ways. The first way is more than one ALU. Look at the point. This is one possibility. Inside the microprocessor, we have only one ALU. If we increase one more ALU, one instruction is sent to this ALU to get processed. Another instruction is sent to this ALU to get processed. Right? This is one possibility. I'm just listing down what are the possibility to apply parallelism. See, as we have already learned in the various about the parallelism in the starting session of this lecture, that parallelism is nothing. If we are eating a bread and omelette at the same time, a coffee cup in my another hand, this is also an example of parallelism. Two activities simultaneously. Makes our processing fast, but this is sensitive also. It needs a lot of control. This is one possibility of parallelism. Another possibility dividing ALU in sections. This is another possibility. Arithmetic and logic unit, right? One instruction steps inside the microprocessor to get processed. We know that every instruction has a different nature. If you're talking about adding two numbers, is a different task. If you talk about comparing two numbers, if A is greater than B, it is a different instruction. First one was an example of arithmetic processing, and the second one was the example of logical processing. So if the microprocessor ALU is divided into various sections, you take the example arithmetic, logic, and shifting. What will happen when one instruction comes inside? The nature of the instruction is arithmetical processing. Send it to arithmetical section and fetch another instruction to get processed. It has a problem also. Suppose the another instruction is also arithmetical processing. Then what will happen? Arithmetical section is busy. You cannot send there. I mean, this design suits to a condition where one instruction is fetched to get processed, and this micro instruction is arithmetical processing by nature. Send it to arithmetical section to get processed, right? Fetch another instruction during that instruction is getting processed. And this the nature of this instruction is logical in nature. Send there to get processed. Fetch another instruction. The nature of this instruction is shift in nature. Shifting the data, like A is equals to B. What do you do? You're shifting the data, copying the data from A to B. This is shifting in nature. So this is looking very perfect possible design of parallel processing. But what if you fetched one instruction? The instruction is arithmetical processing by nature. You said control unit send to arithmetic section. Now microprocessor fetched another instruction, and this is also arithmetical processing in nature. Then again, this instruction will have to wait to get this back, and this is also one possibility of. So we have how many possibilities turned up? First, more than one ALU. Second, dividing ALU in various sections. Third, more than one microprocessor. I repeat, more than one microprocessor. We have the possibility that a motherboard can be designed to hold more than one microprocessor. This is the motherboard of any computer, suppose. This is RAM, main memory. This is microprocessor. This is another microprocessor. This is another microprocessor. More than one microprocessors are working together. Every microprocessor has its own MU, memory unit, CU, control unit, ALU, arithmetical and logical unit. We have learned that there are different types of computers: microcomputer, mini computer, and mainframe computer. What do you know about mainframe computer? Mainframe computer is that computer which has more than one microprocessor, and all the microprocessors are working together. One microprocessor means one computer, but this is possibility. Nowadays, this is very famous. In any large organization, take an example of Indian Railway. There are more lakhs of its nodes are spreading across India for booking the ticket and doing their administrative tasks and all. And it has a central central computer, which is a server controlling all computers. The server is mainframe computer. It has many microprocessors. All microprocessors are working together, coordinating each other. Now, if suppose there are 100 microprocessors, accordingly, we have to increase the size of RAM. We know very well that the size of RAM can be increased anytime. In our ordinary laptop, we have the facility to increase 8 GB, 16 GB RAM very easily. What to talk about mainframe computer? It will have a list of slots to put a lot of RAMs. So that there should not be shortage of main memory at any point of time. So this is one more possibility of applying parallelism in computer science. Now, there is one more possibility I would like to add. We know that microprocessor has MU, which is an organized collection of gates. CU, which is an organized, sorry, I repeat, microprocessor has MU, which is an organized collection of registers. CU, which is an organized collection of gates used to control the overall activity. And what is ALU? In a very ordinary definition, in a very ordinary line, we talk about ALU stands for ALU is arithmetical and logical unit, which is used to execute more than, which is used to process the instructions sent by CU. Now, talking about internal structure of ALU, we should know that ALU has a lot of circuits like adder, subtractor, multiplier, shift registers, counters. These circuits processes the instruction. We all know. What is adder circuit? Adder adds the data. What is subtractor? Subtract the data. Multiplier multiplies the data. So ALU is an organized collection of these kinds of circuits. So there is one more design possibility to increase more number of adders, subtractors, multipliers. Am I right or no? So that these can be used if once one instruction stepped inside the microprocessor, which has to add two data. Another instruction fetched, and it also has to add the data. The add circuit is busy at that time. Now, what do you do? If we have one more, data to be added, one more instruction whose data has to be added, then what do? The computer will send that data, that instruction to another adder circuit available. So what are the fourth possibility? Many adder, subtractor, multiplier, etc. So in this lecture, we learned about the power of parallelism. Nowadays, we talk about dual core processor. We have i3, i7, different kinds of processor available. These processors is fully implemented the parallel processing mechanism. Thanks for joining the session. Thank you. Bye-bye. Take care.